Hey there, I'm Juan Aguirre, and today I'm going to be working on the Sudoku front-end challenge. So let's get started. Share my screen and let's start the clock. Start. Okay, well, PM dev. Sudoku board is a 9 grid with 33 subgrids. Okay, requirements. Each subgrid can only have digits from 1 to 9, and digits cannot be repeated. The user should be able to put a number 1 to 9 as long as it does not violate rule 2, and the user should be able to clear the board. Okay, so let's get started creating the initial puzzle. Um, I will do a hard-coded puzzle, but in the future we can consume an API or create a function that generates random puzzles. So const initial puzzle, and this will see an array of arrays where we have null or empty. So here we have an array m1 null null. This is a subgrid, and let's create the another ones null. Okay, 3, and now we have one row, we need eight more. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, for example, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so now we have to, I mean, we need to handle the board, new board. We also have to handle the the value handle on change, where we validate if it's an edit or is an add, and we have to validate the row, the column, and grid, because um, the user only can add 1 to 9 and the digits cannot be repeated, so the validation is on the unchanged. Um, we also have to clear the board. Clear the clear the board. Mm. Okay, so for the new board, we can do a use state const board set board use state, and we need a copy of the initial puzzle, as it is an array of arrays. We cannot, I mean, we can not use initial puzzle directly. We need a deep copy. So we can do initial puzzle dot map, and for each row, oops, we copy the row. Cool. Um, and now we have to map the board. So this will be main, and here we will have the table. Um, the table has a table head and a table body. We don't need the table head, so let's go with the T body. And now we have to map each row. So we have a T row and then the columns. So uh, um, for dot map here we have the row and the row index, and we return a T row where the key is um, the key is um, row index, and here we have to map the row. So um, row map. Here we have the cell and the call index. So here we use a TD, a table data key equal to um, um, we can use call, yeah, call index, and we can use the row too. Call row. Okay. Here we have inputs, an input, and this input um, will be type text. Uh, it will have a value. A value is the cell. Um, and let's see what we have. Cool. Um, these inputs cannot be, we cannot edit them because they are part of the initial puzzle, so we have to fix them. Um, so here we do return with the logic here. Um, we have to find the cell in the initial state, and if it is different than null, I mean it has a number, it's fixed. So const fixed equal to initial puzzle dot row index and call index null. So if it's fixed, we can put read only fixed. Yeah, we cannot edit it. What else? I'm thinking. I use type text because if we put type number, number looks like the correct option, but with type number we have the this and we have the arrows, and we don't want to show them or hide them. So just type text, and we validate that it's a number in the onChange. Also, we can put a min length, a max length of 1. So with this, we we know that the user cannot enter 10 or a number of 2 digits. Um, Also, I think we can use min. Min can be 1 and max can be 9. So if I click A, 1, 2, 3, 4. Okay, no, it didn't work. I'm going to comment it. Okay, so we have to create the handle on change. Okay, function handle on change. Here we need the value, um, and we need the row and the column to set them on the state. So row and col. Okay, and here on change we have the event, and we call to handle on change with event dot target dot value, um, row index and call index. Cool. Um, so now here, um, as we can only accept numbers on the unchanged, we have to identify the input numbers from 1 to 9, null or empty string when we are editing, and we have to return when the user enters a letter. So um, we need first the edit, or let's add the first the add case, and then we handle the edit. So um, edit add. So const num will be number sub val. Um, if the user enters an A, we can use the function is none, and with that we can return and not set the state. So const is none equal to is none, and none is not a number. So if is none, return, and then we have to set the value to the word. We need a new word, so const new word equal to, we can copy, yeah, we can do the same, word dot map, we have the rows, and we do a deep copy. Oops. Now new word, row and call, yeah, row and call will be num. Cool. And now set board, new board. So if I click A, oh, value is not defined. Is value. Um, A, no, I shouldn't click A. Oh, I'm doing a miss. A mess. Um, I will add the edit case too, to can delete the states. For this, we are deleting, so the cases are empty string or null. So if value equal to or value equal to null, we do the same here. Console new word, and this will be null, and we return. Let's see. Yeah, cool. Um, okay, with this we can yeah, with this we handle the state. Okay, we have the edit. Now handle the add. Okay, let's see here. Console.log. We can do num and is none. Put is none false. Why if is none turn and is setting it? Um, we delete a value a. Um, is none true and return. What's well, I can find the error here. Well, I was thinking that here I can enter 0 and we don't want 0. So if or num less than 1 or num greater than 9, return 2. So 0. Ah, because value is an string. Ah, but wait. Num console log value num and is none. Let's charge a. Okay, a num none and is none true. 0. None. Console log, edit, console log, add. Let's see. A two add. I think it is, yeah, because value is cell, and here, if it's not cell, it's an empty string. Now let's recharge. Yeah, cool. Now this. Okay, so now here we can write 1, 2, 3, 4, 6, 7, 8, 9, 0 we can't, and 8 near. Okay, so here we have the validations. Um, Here we have validated that is none, none less than 1, none greater than 9. And now we should be able to add if the number is on the row, in the column, or in the grid. So let's validate that. Okay. Um, we can do a for loop. Um, we know the max. Each array has 9 slots. So for let e less than 8. Mm, So if we have to check by row and column. If m var if var sub row, we check the row by and row I um, equal to num return. We with this, we the first iteration is 1. If I click 1 here, I shouldn't be able to put it because the for loop find it and returns. Let's see. Cool. With 1 I can. With 2, yes. Here I couldn't put 1 or 2. I can put 3. Nice. But here I cannot put 3 because it's on the column. So let's implement it. This should be similar. Is or how to use the column. So we need the index first. Index first. So we are here and then the column. So column return. Okay. Um, Here I can nice C call. Sorry. Okay. 3 I can't. And here I can enter 3, but I shouldn't be able to enter 2. Cool. So 3. and 2. Amazing. We have validated by row and by column. Um, what is pending is by grid. Um, by grid. We need the start row and the start column. We have 0, 1, 2, 3. Okay. Grid start call and start row. Const start row equal to mat floor um, row divided by 3, I think. Um, and we multiply by 3. And with start call, let's see what we have. Start row and start call. Um, we have, I cannot put, let's see, 4. We start row 0, start call 0. So we have these 3. If I put here, start call should be start row should be 0, 1, 2, 3, and call 0, 2. Let's see, 5. Cool. So let's do the for. So we need a for loop. Um, um, we need two fors, one for rows and one for column. So let row equal to start row less than. We have to, we know we can move 3 pointers and 3 slots. So row less than start row plus 3. Cool. And now we need the for loop for the columns. For let's see equal to start call and call less than start call plus 3 and call plus plus. Okay. So now if board sub r sub c equal to num, we return. With this, we shouldn't be able to enter um, on the same grid. So, for example, here we have the 3, and here we have another 3. So let's remove them, and we shouldn't be able to add it. 3, cool. So for neither, nice. We can put 5. Um, here what we can put, here we can put 6, nice. And 7 and 8. Cool. And yeah, there is a duplicating. I was thinking that where is the nine? Um, I think we can replace both. Here, nine. Cool. Um, and here I cannot put one. I cannot put five by row. I cannot put six, and I cannot put three by column. And then by grid, um, I cannot put four. I cannot put two. I cannot put seven, and I cannot put eight. Cool, amazing. Um, so nine. Um, what's pending? The user should be able to clear the board. Okay, this looks easy because it's just copy the use state implementation and function clear board, clear board, and set board initial state. Cool. And now table, we can put a button here and clear board and on click clear board. Cool. So if I click it, the the board is cleared. Nice. Um, let's see. Oh, I like it. Nice. 30 minutes. What can add? We can add styles. For example, for each fixed for fixed cells, we can add another background, and we can add a valid board button. That's easier because as we have all nulls, I mean we have an array of arrays with numbers and nulls. If and we have the validation on the on runtime, the initial, I mean the state should be full of numbers. So what we can do is const valid valid word set set valid word use state. Um, we can put undefined undefined. So here can be undefined or boolean. So when we clear the board, set valid word and define, and we do the function validate word. Here what we can do um, is is valid const is valid um, word dot every row and now row dot every and let's see what this return because we need um, I think we can do a flat dot flat or dot flat Mm. and set valid word is valid. So now We add the button, validate board, and click, validate board. What we can do, valid board, um, valid board is not true, it's not undefined. The else null. This is true that if valid word is undefined, we don't show something, and if true, we show valid word, and if not, false. So what we can do here is add a ternary valid and um, valid word because it's true or false. Let's see. Um, valid word. What I'm showing? Yeah, valid. Um, ah, um, no, I think we have to do the flat didn't work. Every row. Um, oh, because here row dot. Here is the problem. Every row dot every cell. Now I hope it works. Valid or false. Cool. Um, well, and to have the, the valid true, we have to complete all the Sudoku, but it will take some time. And well, that's all. See you.